Assalamu alaikum, dear students. I hope you are doing well and waiting for the reopening of your school. Inshallah, we will come out of the current crisis of corona pandemic and will restart our educational journey with full gear and strength, inshallah. My prayers and good wishes are with you. Let's come to our today's topic, which is Bohr's atomic theory. This topic is from chapter number 2, chemistry in class 9th. The chapter number 2 is about structure of atom. And the topic which is selected for today is Bohr's atomic theory. Now, in 1913, Niels Bohr presented a new atomic theory to overcome the defects of Rutherford's atomic model because Rutherford's postulates could not explain the stability of an atom and line spectrum for an atom. Right, beta? Dear girls, you might have studied Rutherford's atomic model. It described the structure of an atom, but there were a few drawbacks, few defects. Two of those drawbacks were explained and removed by Bohr by using quantum theory of radiation, which was proposed by Max Planck. Bohr's model is based on his assumptions about the stability and line spectrum of an atom, which remained unchallenged so far and are the best logical points. Now, let me tell you about the drawbacks, two drawbacks in Rutherford's atomic model. The first one is, according to Rutherford, electrons, which are charged bodies, should continuously emit energy while revolving around the nucleus, and ultimately they will fall in the nucleus. However, it does not happen. Right? Rutherford says that electrons, which are charged bodies, and they revolve around the nucleus, but while doing so, they continuously emit energy. And by continuous emission of energy, the electron may lose all of its energy and it ultimately fall into the nucleus, and it will lead to the collapse of the structure of atom, but actually it does not happen. And the second drawback in Rutherford's atomic model was that if electrons radiate energy continuously, then continuous spectrum will be obtained, but actually line spectrum is obtained. Now, let me show you the pictures of continuous spectrum and line spectrum. This is the picture of continuous spectrum, where you can see colors, different colors are merged into each other without any distinction. While in case of line spectrum, different colors have their own particular distinction and they are separated from each other by gaps. So this is the picture of line spectrum and this is the picture of continuous spectrum, right? Okay. Now let's come to the points of Bohr's atomic model. According to him, according to the assumptions of Bohr, electrons revolve around the nucleus in fixed circular paths called shells or orbits or energy levels. And each orbit has a fixed energy, right? Let me show you the picture of an atom having a positively charged center. This is called nucleus, and the circles drawn around the nucleus are the shells, energy levels or orbits. And this is first shell called K, second L shell, third M shell, fourth N, and so on. Right? So, according to Bohr, the electrons, they revolve around the nucleus in fixed shells. Right? And each orbit has a fixed energy of its own, right? Okay. Then we come to the second assumption of Bohr. The energy of the electron in an orbit is proportional to its distance from the nucleus, right? Farther the electron from the nucleus, higher will be the energy, and nearer the electron to the nucleus, lower will be its energy. Now let's come to this picture. The electrons residing in the first shell, which is closest to the nucleus, will have the lowest energy. The electrons residing in the second shell will have higher energy than those residing in the first shell. Similarly, electrons residing in the third shell will have higher energy than those residing in the first and the second shell, and so on, right? So, this was the second assumption or point of the Neil Bohr about the structure of an atom. Let's come to the third point. As long as electrons are revolving around the nucleus in fixed circular paths or orbits, they neither gain nor lose energy. That is, their energy is fixed as long as they remain in a particular orbit, right? Here you can see an electron residing in the first shell will have its own energy. Electrons residing in the second shell will have their own fixed energy, right? And then the energy of electrons the electrons residing in the higher the electrons, they will have their own particular energy of their own particular shells. They will, the electrons of the higher shells will have higher energy than those residing in the lower shells. And an electron, when it jumps from the higher energy level to the lower energy level, it loses energy. And when an electron absorbs energy, it jumps from the lower to the higher energy level, right? And as long as the electron remains in a particular orbit, in the same orbit, it neither loses nor gains energy, right? Electron only loses energy when it jumps from the higher to the lower energy level, and when it absorbs energy, it jumps from the lower to the higher energy level. But when it remains in the same shell, it neither loses nor gains the energy. So, this was the third point of Bohr's assumption. As long as electrons are revolving around the nucleus in fixed circular orbits, they neither gain nor lose energy. That is, their energy is fixed as long as they remain in a particular orbit. Now we come to the fourth point, which I have already explained. Electrons lose or absorb energy when they jump from outer, yani higher energy orbit to inner, yani lower energy orbit, and vice versa, right? Okay. Now let's come to the mathematical description of this third point. The energy difference between two energy levels or orbits is given by this formula. Delta E is equal to E2 minus E1 is equal to h nu. Delta stands for the difference, change. E stands for energy. E2 is the energy of the second shell, which is higher energy level, and E1 is the energy of the electron in the first shell, which is lower energy level. H is Planck's constant, and nu, this is the sign of nu, frequency. It is the frequency. So, right, the energy difference when electron jumps from the second shell to the first shell will be represented by this formula. Delta E, the energy difference, E2, the higher orbit energy, E1, the lower orbit energy, H is Planck's constant, and nu is the frequency, that is nu, right?